We have a problem here which is becoming a little more common on the ACT. Every now and then you'll see something like this where they ask you about the correlation coefficient. It has to do with statistics and data, um, and it's really important to know what that definition is because otherwise you're not getting anywhere in this problem. So correlation, if you look over here, correlation is how much data lines up. And by that I mean, how much does one set of data have to do with another set of data? So for example, I could make a statement that is mostly true. I could say taller people are heavier. And it's mostly true, or at least there's some amount of truth to it. If I compared someone who's very tall against someone who's very short, I probably have a good chance that I'm right of saying that the tall person is heavier than the small person. Now, it's not always right because you have some short people who are round and some tall people who are thin. And depending on the roundness and the thinness, it might break the trend of tall people being heavier. But that's what correlation tries to get at. It tries to get at how well the data lines up. And what we have here are 5 different pictures. And I'm going to tell you what the correlation of each of these is. This is a 1 correlation, okay? In other words, this is a perfect match. As X gets bigger, Y gets bigger. And there's no variation in that. It's just perfect. This one right here is 0. This is called no correlation. Or in other words, no match. This is data that has nothing to do. This is like if I said, how tall is someone and then what's their favorite color? These have nothing to do with each other. So there's no correlation between those two data sets. They have no predictive value. And you can see in these other ones, like this one is an anti-correlation. Okay, that's anti-correlation. It's got a -1 value. And these last 2 that I haven't labeled yet are kind of going up and kind of going down, but not perfect. So you can see that they're not 0. They're better than 0. This one's about a 0.75, and this one's about a -0.75 because one's going up and the other's going down, and they're not perfectly related. These might be height and weight maps for all we know, right? Taller people are generally a little heavier, but it's not perfect. So that's what you should be looking at when you see a question that says, which one of these has a correlation coefficient of 0.75? We're just talking about rough estimates. Obviously, it has to be going uphill, and it has to be sort of agreeing, right? It's better than 0, but it's not perfect. So that's what this problem is getting at with correlation.